certification is the certification is not a big issue.
Better be good. We're going to meet again, you know. Okay. Start introducing them. Okay.
Hello everybody and welcome to the CERIAS Security Seminar here at Purdue University. Today's speaker is our own Abhilasha Bhargav-Spantzel. She also got her undergraduate degree here at Purdue University, and today she will tell us about digital identity management and protection.
Thank you. So, as Professor Desiderata said, that I'm going to talk about digital identity management and theft protection. This is my main focus of research for my PhD, and it's got some very interesting problems and very important ones, solutions to which I think makes a difference in each of our lives. So just to make sure, may I ask the audience, who knows what I mean by digital identity management?
What you mean?
What is meant by digital identity management? Just the term. So there are a couple. I hope by the end of this talk you get an overview of the state of the art of identity management, really what happens, some of the basic protocols, and looking into identity theft, which is one of the most important security threats in identity management systems. Okay? Just on time. So the basic outline is as follows. We will go through some basic concepts of digital identity, then look into what were the stages of development of an identity system and the current state. Then we will discuss an implementation that we are doing here in Purdue. It's an open source implementation. Then we will switch gears to a security problem in identity management systems, which is identity theft. And then I will give an overview of our solution towards solving this problem. Okay? So, the basic concepts. This is an interesting question. What is a digital identity? What is your digital identity? And one way of saying it, and there are several definitions out there, is digital identity is a set of claims made by one digital subject about itself or another subject. Okay? A subject could be an actual human being or a process, a resource. But what are these claims? These claims can be assertions of truth about something. These are typically assertions about something which is disputed or is in doubt. It can be an identifier, knowledge of a secret, some personally identifying information, membership in a given group, and even a capability. So these definitions embrace very well-known authentication systems like Kerberos, which is based on tokens, X509, which is basically digital certificates, standards, SAML, which is security assertion markup language, which is the upcoming standard for sharing assertions, and a lot of identity management systems depend on the standard, and there are several emerging new technologies. Okay? So once we have a bunch of identifiers which basically tell who you are, what you have, what you know, what is it really identifying? If it identifies one single person, then it is called a strong identifier. Example of this is a social security number, a passport number. And if this identifier puts you in a group of people, then it is essentially a weak identifier. So, for example, Purdue students might put us in a group of 10 people in this, but 10 or 12 people in this room. So it does not uniquely identify you. And it is a very important distinction to make between the strong identifier and weak identifiers, and seeing the properties while considering the security conditions. So we make this distinction in our work. Okay. Then let us see what are the problems of managing our digital identity. The internet as such was really built without knowing who you are connecting to or what you're connecting to. So what happened was that the different web services tried to compensate it with their own authentication systems. Then they had this patchwork of having their own username, passwords, without really knowing what else is happening, what other web services are offering. So what this led to was a lot of username and passwords. We all know how cumbersome it is to manage these username passwords, which lead to a lot of security threats. So one thing we need is a good authentication system, which helps us make this authentication mechanism much better, usable. And it is not just from the user side. It is also from the service provider side. So some of you might know what I'm talking about. The phishing attacks, right? The phishing attacks can actually fool a normal user for using a site he is submitting information to. So for example, over here, an adversary can mimic or can actually copy the whole template and the looks of this website and get the information of the user, and then use this later for fraudulent purposes. So it is important to be able to authenticate both ways. Another problem which exists in current system is a patchwork of systems. There's a lot of redundant information. I'll try to show that with this example, which is a realistic example, because you go to any company. For example, if Bob goes to company A, and company A requires the name of the person, the address, the telephone number, the date of birth, to be able to provide the service Bob needs. Bob's happy to give that information. But then, as the activity of a user online, it goes to other services, and similar information might be required. So company B also requires a lot of information which was given previously. And just to prove a point, this can really get annoying for a user to be providing information which he might be okay to share if the companies actually shared amongst themselves. So we need a mechanism by which the information which can be shared is shared between organizations. Okay? So there are a lot of interesting problems here, because maybe the date of birth is very sensitive for Bob. So there should be a way to differentiate where he wants to opt in for sharing and where he wants to opt out. And that comes into the whole privacy preferences and policies area. So after looking at the basic concepts, let's look at the desired properties of an identity management system. And to really structure understanding of identity, I will look at a very well-studied paper by Kim Cameron, who is Microsoft's chief architect. He's a very well-known figure in identity management and one of the main persons involved for .NET Passport, which did not work out, and we'll discuss why. Okay? So there are about 10 to 12 laws of identity, and we have time to visit 4 of them a little more in detail. These 4 are user control and consent, minimal disclosure for a defined use, justifiable parties, it's not obvious what I mean at this point, but we'll go into it, and directional identity. So the first one, user control and consent. The digital identity system must only reveal information identifying a user with the user's consent. So this basically gives a sense of control to the user about his identity, digital identity information on the web. So this there are definitely a lot of websites which archive public information or information available online and give it to users for use. One of them, I just put my name there. I was thinking of putting somebody else's, but just to be safe, I put my name there, and there were 7 records found. And anybody without my permission can look into these records. Even if these records are public records, there should be a way that a user knows that this information is being revealed to someone. You can just pay a little more than $10 to actually get more very uniquely identifying information. I see a lot of people writing down this website. I can provide you more information about where you can get these types of websites, and we are working on seeing how we can propose why such websites can actually reveal information which can lead to identity theft. So we do have this desired property that the user control and consent should be there in any identity management system. The second one is minimal disclosure for limited use. There are 2 points here. The solution that discloses the least identifying information and best limits its use is the most stable. Limits its use is the most stable and long-term solution. The first point is that there is minimal disclosure. If you're buying flowers from a flower shop, you don't need to give your phone number or social security number. Phone number is more common. They ask you for it for other reasons. But then we really try to limit the amount of information revealed at any point. The second one is that if you have any information of a user, you'll end up having to secure it or store it in a very secure fashion. So there are lots and lots of news articles that you will find where compromise of information was because it was not secured properly. This photograph out here this was a very popular photograph last year when ChoicePoint had compromised about 160,000 consumers' financial data. And just a couple of days back, I think it had to settle with about $15 million for that compromise. So it can get expensive not to be able to secure such information. The third condition, justifiable parties. Digital identity systems must limit disclosure of identifying information to parties having necessary and justifiable place in an identity relationship. This is a very important point and is well taken by Microsoft as they put the example of .NET Passport. One of the main reasons why .NET Passport did not work is that the users didn't like to go through Microsoft for any and every website that they visit. So if I go to Amazon and buy a book, or I go to eBay and buy some product, why do I have to go through Microsoft.NET Passport? So there has to be the reason of a particular service provider being present in a transaction has to be justified. Okay, so this also leads to the requirement of a decentralized system. You can't have one central party that you totally trust and that one takes care of all your identity information because it may not be relevant at that for a particular service. Then is the directed identity. It is worded in the paper as follows. A unifying identity metasystem must support both omnidirectional identifiers for public entities and unidirectional identifiers for private entities. What is meant here is technologies like RFID or you have the Bluetooth on different devices make you some sort of a beacon which anybody can tune into. So it may be okay for some users to get certain amount of information, but you want only authorized users to actually get some other kind of information which may be sensitive. So it is directed to either everybody or directed to some authorized people. And this again leads to the requirement of authentication, for different types of devices. So those were the 4 desired properties, and definitely we have a much more detailed list, which I can provide if needed. So we go to the next thing is to look into what were the different stages of development of identity management systems. Okay. So the stage 1, which was the most intuitive, was that every application for itself. So all the authentication, the logging functionality, everything was done per institution. They did not refer to somebody else's logging logs to be able to make some authentication decisions. So this led to, again, multiple passwords, and which led to another set of security problems. But this was the initial stage, and although there are definitely many institutions which still have every application for itself identity system, it is heading towards something better. And what was tried was the second stage, which was the central authentication system. I would put the .NET Passport into somewhat this category, which has a central authentication system which enables single sign-on. A single sign-on is you sign on once in the system and then you can be seamlessly authenticated in the different websites. Okay? This was the beginning of federated identity to simplify collaboration amongst different institutions. So there were problems with this, and it was rectified using this particular kind of architecture which we are heading towards. And this is our main focus on how to establish and what are the different types of problems in an identity system of this kind. Here the workflow task automation is given very clearly. The rules and rule-based authorization is defined. There's a system-wide auditing and reporting. This is actually very interesting, where how the history of users' activity at different service providers can affect the authorization decisions at a service provider the user has not visited yet. So how can this information be gathered efficiently? Because remember, one of the most important functionalities of an identity management system is to provide a usable environment. If it is absolutely secure and not usable, then this cannot work. So this system basically gives you federation of identity information. So in the last two slides, I use the word federation. What does it mean? Federation is basically a circle of trust concept. Now this circle of trust is made of organizations which agree on certain policies, on protocols, standards, and how they're going to share and authenticate its users, right? How it's going to share the information, how it's going to store. There are a lot of standards that they have to agree to. This is a real thing. There are a lot of federation initiatives. Two of the popular ones are Liberty Alliance Project and Shibboleth. Liberty Alliance is more of a corporate initiative. It is an alliance of more than 150 companies, non-profit organizations, and they establish open standard for federated network identity. You have several working groups, and I'm working with one very closely for identity theft, and it's a very active group which tries to give you best practices, what is the best way of protecting information, and establishing standards, which is extremely important in this area. Then is an open source implementation of a federated identity management system, which is called Shibboleth. And here more than 200 universities, Purdue included, are members. And we are currently trying to implement this system and even extend it later to be able to share resources, information from different universities. So if I want to access a digital library from IU and or maybe some resource, some network resource, then I should be able to authenticate in a manner which is very easy. So basically, the point of these two of this slide is to show that they are initiatives which actually implement such a system. And Shibboleth and Liberty and the other initiatives are working on interoperability using the security assertion markup language, that is a SAML 2.0. So I would now like to describe further the actual step, the protocol taken for an identity management system. In this case, the Shibboleth implementation at Purdue. So what does this Shibboleth implementation provide? It provides a set of network services that support the federated authorization and authentication model. So it gives us an architecture, and it gives a set of protocols which is based on SAML. And it emphasizes the privacy and the trust management. And we are currently looking at how we can provide accountability in the system and extend it to use it in grid systems. There's a big TerraGrid project here at Purdue where we are trying to see how the Shibboleth can be used. If there are any questions, I know it's halfway through, but if there are any questions, please let me know. You can just raise your hand. We can discuss one particular point. So, what are the main players in an identity management system? You have an identity provider, which issues identity. Okay. So here, Purdue University might issue me a username, password. It can also issue me digital certificates certifying that I am a computer science student, or certificates can assert different properties. Then you have relying parties, or you have the service providers, which basically give you services, and these services can be online. I'm basically considering service providers which are online. And then we have subjects, which can be individuals who need these services, right? Okay, so step by step, consider a student of Purdue. Let's call him Pete. Okay, so you have Pete who wants to access an online book in IU. Okay, IU doesn't know, he doesn't have a login password for IU. So IU requests Pete, I don't know who you are. So it pops up on the browser something called WAYF, stands for where are you from. Okay, this where are you from will basically ask Pete, select one of the institutions in this federation as your home institution, who would know who you are, where you can be actually authenticated. Pete's like, okay. He selects in the drop-down list the institution. So this page looks like this. You can see Purdue University, and we can actually do that now. You can select the Purdue University and be redirected to the Purdue University authentication webpage. Over there, so Pete gets redirected to Purdue. It can be LDAP, whatever Purdue uses to authenticate, that mechanism can be used. So it opens a familiar browser which asks for the username password. Then Pete provides his username and password. It could be other credentials depending on the service. It could be a smart card, some biometric. But whatever Purdue needs to authenticate. At this point, Purdue knows who this subject is and is able to retrieve more information about this subject, considering that each of the identity provider has a record of information about this particular user. Okay, so to keep the privacy of Pete, the identity provider would not go, in this case Purdue would not go to IU and say, hey, I have all this information about Pete. Instead, he will make a handle, or Purdue will make a handle at step 8 to be able to communicate about this subject. So this random handle does not give any information about Pete other than the fact that Pete is authenticated, and I can give you more information about Pete. Okay? So if for the online book, Pete needs to be a CS student and say needs 12 credit hours. So at step 9, using that handle, the IU actually asks for those credentials. Then IU says, I need these and these, this and this information. So now Purdue will check if this information can be released to IU, or would the consent of Pete be required. So based on that, this information is given at step 10 to IU, which results in satisfying all the conditions that is needed to get the original request of Pete at step 1. So this basically shows how the system works. And then at each step, there is a very well-defined way of how the request is made, and it's a very efficient procedure. And about 200 institutions can replace the service provider here at this particular time. So what are the key benefits of using Shibboleth? The remote service providers do not have to manage the user lists for every institution that uses their service. So IU does not have to make a list of all possible users that may come from different institutions. It also allows home institutions to protect their identities from their users from remote services, provides privacy. Because what happens is that if I can, again, the minimal amount of information has to be given to the other service providers. I may trust Purdue for securing certain kinds of information, but may not want to release a lot of information to the service providers providing the services. So how do I keep the minimal amount of information and keep myself anonymous as much as possible to the different service providers? Then it also leverages the existing authentication systems at home institutions. This is a very important point because it is not trying to build a whole new system and remove all that existed before. This is on top of the current authentication system that is being used today, and just adds another layer to be able to do the collaboration. And again, it gives a flexible distributed architecture that supports a variety of usage scenarios. So I just gave one example, and there could be different ways in which you can authenticate a user in a distributed environment. Now, having done the basics of identity management system, I would now like to go into one of the main security problems in any identity management system. So one of the main reasons why security problems exist is because of the contradictory requirements. Because on one hand, you need availability and usability. You want this information to be shared so that you don't have to keep on giving the same information everywhere, be able to easily access services. But at the same time, you want privacy and security. You don't want the wrong people to get this information. This is like weblogs you want everybody to see, but you don't want them to. You don't want anybody to see which newspaper you're reading or which eBay product you're buying. So there are two contradictory requirements. And one is that of identity, and no, it's not a requirement. And one problem is that of identity theft, because what is identity theft is the use of personally identifying information belonging to one individual by another individual for financial and personal gain. This is a really serious problem and is being taken up by different institutions. And the way they deal with it is depending on the type of attack vector. A very well-known way of describing the different threat is by looking at the different attack vectors. You can look at it in the technical aspect, the physical aspect, and social engineering aspect. And all three of them are very real. And we consider them as we are developing solutions for one area. In the technical aspect, you have farming, network sniffing, keyboard loggers, database attacks. So you can have a lot of technical attacks. On the physical attack, not enough people are shedding their mail, so you have dumpster diving, you have trusted insiders, you have just theft and loss. Then you have the social engineering aspect where you can have the legal identity sources. You can, like the one we saw earlier, then you can have phishing, you can have family members trying to get information. So there are different there are different reasons, the ways of attacking identity system. And the recent FTC report shows that 37% of the entire set of complaints, which was 686,000 complaints, leading to a huge number, as you can see there, a huge amount of it is just identity theft. So it's a big problem. And what are the main causes? So before we look into how we can solve it, we have to check, okay, what are the main causes of identity theft? The main problem is that there's a loss of control. It is easy for identity thieves to assert that they are someone else with the right data. So, for example, my sister's mail comes to our same house. I can see the last 4 digits of a social security number, which are given for security purposes. But guess what? That is sufficient for me to assert that I am her if I'm calling up a financial institution. So I know the date of birth, I know the social security number, only the last 4 digits, and a bunch of information which friends, family might easily know, and an adversary can know that too. So that is the first problem. It's easy to prove that you're someone else based on some data which you can achieve, which you can get. Second problem is that the actual victims may find it difficult to prove that they are themselves. If someone actually went off and got their identity, a real person may have a very tough time getting back their identity. So one has to take into account that there is already a lot of information of individuals available at different places. So there is information which I can't take back. You can't start issuing new social security numbers, each and every attribute cannot be reissued just because it was available at one point. So our solution has to take into account that this information is already there. Now what we can do to counteract for these particular problems. So we published a paper on basically establishing and protecting digital identity, and you can get more information regarding this from me later. And what we really looked at is how do we establish a digital identity in a particular federation, and then detail out, okay, for identity theft protection, how can we use secure message exchange protocols and tools like cryptographic zero-knowledge proofs and distributed hash tables to prevent identity theft. And we will get into that now. And then we also give formal and detailed analysis of the security and complexity of our solution. this was, again, an important aspect because we can give some nice tools, but if they are totally inefficient, then it cannot be really used in the system. So the main idea behind our solution was that of multi-factor. So having known that we have a lot of information, one can look into seeing that, okay, if you can provide additional information, for example, your mother's maiden name or social security number, as a proof to qualify the owner of this identity attribute being used, like the credit card number. It's a very real life thing. You go to a bar, you go to a shop, you find that if you use, say, a credit card number, it is likely that the seller would ask you for a little more information than that. In this case, they ask for a driver's license or additional photo ID to assert. But if you think about this further, in a digital world, asking for more information does not mean that you can take it back. If you gave more information than required, you just needed to give your credit card number. And just to prove that this is your credit card number, you'll end up giving up your social security number or additional information. That's gone. Now the actual service provider knows all this information. So you can't really show that ID and take it back in the digital world. So the idea is to provide a multi-factor without the loss of privacy. And for that, we use a zero-knowledge proof, which is an interactive method to prove the possession of a secret without actually revealing it. So the zero-knowledge proof is used to prove the knowledge of the strong identifier. Okay? Because normally to prove that this is really you, they'd start looking at strong identifiers related to only that one single person. And zero-knowledge proof does not need one to reveal this actual information. Then we also use, if we have time, we can look into the distributed hash tables, which are used to prevent malicious users to be able to get these proofs. And we'll just check that. So we considered different types of attributes. There are mainly three types of attributes. First, in a system, the user establishes a single sign-on ID. Now the user can actually log into the system and be known as a particular identifier. Now once this single sign-on ID has been established, you can voluntarily give information which cannot be really verified because it's not signed or it's not certified. So these are the uncertified attributes which do exist a lot in the system. And we argue that protecting these uncertified attributes is also quite important because most of the information that you give today is uncertified. I don't know how many people use digital certificates to get a lot of services. So how do we protect these? But then also have to consider the certified attributes because these are also used for more higher security services. So what we do is we say that we will add proofs, the concept of being able to prove the possession of these attributes without having to reveal them. And we will then call these attributes secured from identity theft. So that's the SIT. Okay. So there are two main phases of our solution. First is when we enroll or register. Here the user commits his strong identifiers to be used later as proofs of identity. Now these are the SIT attributes which I had described earlier. So once this commitment is made, what the user can do with these attributes is be able to prove that he knows the value of this attribute by presenting some other numbers without presenting the value of this actual attribute. So I can prove that I know that my social security number is so and so without really giving you the actual number. Okay? So these proofs are stored with something called the registrar. Then at the time of usage, before revealing the actual sensitive identifier, in that example it would be the credit card number, before revealing the actual sensitive identifier, these proofs have to be verified. That are these proofs correct? These proofs that you're giving me. So the example is as follows. Bob goes to the registrar. This is the registration phase. Okay, he tries to register his credit card number and social security number. What happens is that they get into one of the well-known zero-knowledge proof protocols where they land up setting up committed values. Now, these committed values are actual proofs which are used later to show that they know the values of this credit card number and the social security number. I'm omitting the details of how this zero knowledge proof goes because of lack of time. But the idea is, using these committed values, one can prove that I know the value of this social security number. Notice that in this particular record, in the record given in with Alice at SP1, which is a single sign-on ID, the actual value of the social security number and credit card number is not given. So this record can be public, and it will not leak any information other than the fact that the social security number and credit card number have been registered. So that's the only amount of information you would get from that. Then, at the time of usage, you would have a service provider. When Bob requests for a service, then the service requires a credit card number, and to use a credit card number, one has to prove the knowledge of a social security number. Then, just as we saw in the previous example with Pete trying to go into get a service from IU and looking into the authentication system of Purdue, we use the same mechanism here to be redirected to the registrar and be able to get the committed values, the proofs associated with the social security number. And these values can be used used by the service provider to check if Bob actually knows the values corresponding to the social security number tag or the credit card number tag.
So the registrar does not know the values of the social security number and the credit card number?
No.
No, he doesn't?
No. So these values are committed. And that actually brings us to a very interesting point. I will just try to be very short on that. If the registrar does not know the values, he also does not know whether these values are correct or not. So that led to a nice way of, we established a technique for lazy validation. So at some point, whenever this was used, then the correctness of these attributes registered was checked. And then this is later updated or indicated by the original registrar. So we have pending states, and we update this state as the user actually uses the system. So if you use the system more, you're known more, and then people can assert strongly for you.
But if the register does not know the values, so what are you committing? What is the register committing?
So you're committing a secret. Like if you commit a secret, that secret doesn't need to be revealed to the person you're committing it to. So I send it to you. It's not really a hash, but if I send you a hash of the secret, you can keep that hash and not know what is the value inside that hash.
Basically, I don't understand why you have a register.
The registrar
He doesn't know what's the secret, and the service provider also doesn't know what's the secret. So they both don't know anything about it.
But once you can reveal the secret, it can be verified whether the secret you committed was the secret. The secret you.
Information it actually allows them, once you committed to that, you cannot change it. So whatever information you give afterwards,
Right.
identify yourself is based on that secret. The commitment value allows you to verify that indeed that's what you use. But I also have a question because we're talking about the lazy verification.
Right.
So to know that this, let's say that it's not going to commit the
authority. So we're actually working within the federation. So within the federation.
That means that somebody, what I'm trying to say is that if nobody else knows that, there is no way you can know if it's correct or not.
Right,
You
right.
have only one source of information.
So that is absolutely correct. If nobody really knows other than the user that this information is correct, then there is no way to check if this information is correct. But then that's where we start looking into multi-factor. If you can tell me that all the credit card numbers associated with this person in the same record have been verified correct, and so then we have a probabilistic argument that all this information is correct, then it is highly likely that this information is correct. But for most of these,
Assuming that the guy lies inconsistently, but if he lies consistently,
right,
then
right.
I don't see why.
And we have a very strong analysis of such a situation in which, if the first time the enrollment is wrong, what do we do? If an adversary registers his social security number with the credit card number of some stolen credit card number, then what do we do? So that's why the security analysis becomes very interesting, because for most of the credentials, we would say that there is somebody outside who can actually verify this information. And there is an in-person registration phase also. We say that if this does not work, then we have to look at in-person registration procedure or verification procedure.
So one suggestion that I have is actually have to be more specific about exactly the problem that you're addressing, because you're not addressing the first phase, and that I think is probably the most important. So you have to position whatever your work is doing with respect to these are the assumptions that we are making kind of, so maybe that's why there's some confusion here, because there is nothing about the assumptions that we are making.
Right, and the paper gives you a very detailed set of what is a security model, what are the assumptions, it gives a step-by-step procedure. Okay, given that these assumptions are true, then we will have either in-person registration, or because for some cases, as Professor Nita Rotaro said, that it's hard to check with an outside authority whether this is correct. But we do account for that in our paper, because it actually is much more complicated than that. If you start looking into even the credit card numbers, they time out over some time. Some things get reissued. Even shared credit card numbers, the husband and wife are using the same credit card number. There are very interesting issues in this aspect where it's not so easy to be able to assert something about a registered value. But the main idea I wanted to present in this presentation is the fact of being able to associate a proof with an attribute. So if you have this proof, then you can use it to give multi-factor authentication.
But usually someone has to prove that what you're trying to prove is right? Yani, if you are trying to say that this integer is greater than 5, it has to be greater than 5 before you prove it, right?
Right.
But what you are trying to say is that there is no one on earth other than the guy owning the number can prove that it's greater than 5.
Right.
In this case, in this scenario.
So as you see over here, the social security number is given as in person. So one can say that this card was shown and this one was registered at the time of registration. So I can be sure that this identifier is really of that person who is registered. So over here, the proof is correct. That if I can prove you that I know the value and this value was registered in person, then one can be pretty sure. But the challenge comes when this is not in person. Then when you're sending a number online and you're not really showing the number, then how do you make sure that this number is correct? And that is a big challenge. And how we do it is by step, how we have to rely on some authority which can prove it. And really, if you take it to the end, it's very difficult unless you go in person, or you have to come to one level where you have to rely on something. You can't keep on building on top of each other. But we can discuss this further in detail later. But the main idea over here is again that if you have some way to prove that this is yours based on some multi-factor, this can actually help a lot in being able to prevent misuse of information outside. Okay. And we show also that without giving the proofs, one cannot really use the actual identifier. So if I want to escape the proof, we show that how we somehow in the protocol mandate the fact that you need to do the correct protocol before you can get to the step of actually providing the credit card number to get the service. Okay? But that's good discussion and we can elaborate on that. Just a quick note about how to detect duplicates. The question was, if one has already registered some identifier, for example, a credit card number, and somebody else tries to register the same credit card number again, I should be able to detect that. And to do that, you can just put the identifiers, hash it, put it in one table. But if you have thousands of hosts and a large hash table decentralized, how do you really detect this duplicate? So you can't have a centralized authority again. So to do that, you can have a distributed hash table. This is just one technique that
Yes, no problem.
Yeah.
You are going to hash the credit card number?
It can be the credit card number.
No
Actually,
one
we're
knows
hashing.
the credit card number, right? In this system, no one knows the credit card number, and it's not displayed to anyone, right?
Right.
So you are assuming that the proofs are the same.
The proofs of each.
Yes, so
yes.
that's...
That actually has a very, if you use semantically secure zero knowledge proofs, which add random.
Really the same.
Sorry.
If you use the zero knowledge proofs.
If you use deterministic zero knowledge proofs, then then if you commit the same value,
yes,
it will be the same. But you will have, like, it will be good if you go through it, because this was very interesting, because you can have a brute force attack if you have deterministic commitments, because these are 9-digit numbers, 2 to the 50 computations, a few hours of work, and you can actually break certain commitments. So what do we do to be able to handle that is actually elaborated in some follow-up work. But that is a very good question about what is really the key of these hash tables, and these are not really the hashes of the original identifiers. So there is a way that we randomize it and put it, but that has to go into little more details. And there are other things too, if one party goes down, or the reliability aspect, and how much redundancy we need in this particular federation. That's really good, though. But there is some basic concept here about adding proofs and not really checking at every step that a user uses it, but at certain points one can check for the validity of this information. So, and also not releasing this sensitive information by using those zero knowledge proof. Then we can assure the validity of some information in the federation. And as different service providers keep checking the validity, it could be credit card numbers. For some you cannot check, but for those that you can check, one can somehow leverage the validation done at different service providers for the whole federation in itself. So you can have a higher level of assurance. Then we provide a flexible approach, and this is ongoing work of the lazy validation approach in a federation. And then the distributed hash table is something that we're implementing at this point to see how well does it really work in practical federation systems.
So what is your assumption about the members of the federation? What if one member is compromised? And
right.
Ultimately all these federation members are servers, and the whole idea is that if you compromise the client, you can compromise anyone.
Right. So the service providers, they can be either compromised or they can be malicious, and in different cases.
So how if that's the case, how will you even verify? I think that nothing works if indeed even one of the server will be compromised.
Actually, it is even if the service provider does not really get. Talking about identity provider.
I'm talking about one of the members of your federation who's doing this lazy validation and is maintaining the hash table.
So there is redundancy there, because there's not one service provider and it is the only person who has all this information. So we do replicate information within the service provider. So if n of them are compromised or are not working, then we can do something about it. But that.
How many, for example, how many replicas do you maintain? How many malicious servers can you use?
So this actually goes on to the details of distributed hash tables, which I'm not focusing on right now, because this is something this is the next step, Once we said, okay, conceptually we can look at distributed hash tables as being one of the ways of being able to detect duplicates. There are other ways too that we are seeing, which can be actually practical in our approach. But these are interesting points of, how many can go down before the system goes down. But it is really implementation details, which we are looking into. It could be malicious, it could be sending messages of different kinds. Yeah.
So I want to ask a small question. So you are assuming you are providing a privacy solution to the problem, right?
Right.
Is it a solution to the privacy problem? So in this system, can I find how many credit cards do you have?
If you have the same identity provider,
yeah,
and you've registered all of them in the same place,
yeah,
then if you can get the information from the identity provider, then you can potentially use it. That is assuming that the identity provider can release that information to you.
Yeah, but if you think about it, every time I try to register or I query the system to see if whatever I'm trying to register is already in the system or no, right?
Then that comes into whether you get like whose credit card number is it, and we add randomization so that you really have to guess a lot to be able to guess if this number exists in the system. The randomization really does help, and it opens up some really interesting challenges. Okay, we have 2 seconds remaining. No. Just concluding that this actually has, as the discussion showed, that they're very interesting problems. We have been working on this for about a year, and we have some preliminary results, and looking into it deeper would open up different, more interesting issues. And like the main idea that we really focused on till now is the multi-factor authentication. We are also looking into how biometrics can be incorporated in this, and really how we can develop authentication policies to be able to have a nice system where you can actually guarantee something about the user, keeping the usability aspects. Okay? So, questions? This is an actual quote from the movie, if you saw it.
Now that between me and we
But those are very valid points, and this is what we are working on.